This is a project that is going to be an addition to a project I did a while back. I had an old Yaesu UHF repeater which I repaired, and this unit does not have any means of identifying using Morse code to automatically transmit a Morse code identifier. So the purpose of this project is to build a circuit that will automatically transmit the call sign at the beginning of the transmission and then retransmit that identifier every 10 minutes or less. I can set a timer wherever I want. But anyway, in front here is a block diagram of what I came up with. I'm basically using an Arduino Nano here to generate the actual code. I can program the Morse code signal that I want to transmit. The actual tone that's going to be fed to the transmitter is developed in a 555 timer. Now this is configured as an astable multivibrator here. Now they generate a square wave which I don't want to feed the transmitter, so what I did, I ran the output of the 555 astable here through a low-pass filter and converted the square wave into a sine wave. So I've got a fairly clean sine wave on the output here. So the way this circuit starts out, on the left side here, it's a COR, that's a carrier operated relay. When the transmitter is initiated, this contact in the repeater will close and it'll provide a positive going pulse or signal on this line here. And so what happens there is I've got an inverter here that will invert that positive going pulse. Normally the output of this inverter is high. When the carrier operated line goes high, the output of that inverter goes low, and that triggers this monostable 555 here. And this is set up to have a timing of approximately 10 minutes, maybe a little bit less. So when the output of that goes high, it's fed through another inverter here, which converts that to a low output. So this is normally high at this point. So this capacitor here is at a positive level. So now that same positive input that comes in goes to the input of a 2-input NAND gate. So what happens is when that carrier line goes high, this input B goes high, and because of this capacitor, it takes a short interval for A to become high. So when these 2 points go high, the output of the NAND gate goes low, and that is fed to the Arduino Nano, and that triggers that to output the program that I have in it. Now the program in the Arduino here will not run unless this point, pin 4 here, is taken low. And when that happens, the output pin, which should be pin 9, that pin goes high and feeds the upper 555 here, which generates the tone which is fed to the transmitter. Now when that output initially goes high, which of course is fed through the inverter, there's a slight delay because of that capacitor. But then when that output is high, this point goes low. And this is a 2-input NAND gate, so the only way this output can go low is if both A and B are high at the same time. And that's only for a brief instant. In other words, there's a short pulse output on C, the output, that triggers the Arduino. So for the 10-minute period that this timer is running with an output high, it's feeding a low to this point. So in other words, the output of the 2-input NAND gate is not going to go low. so the Arduino will not trigger. At the end of 10 minutes or wherever I want to program the time of this one here, that will drop low again, which will make this point high, and it'll wait for another trigger, which will sequence it all over again, and it'll send the code. So the result of this is you'll have an initial sending of the Morse code identifier at the beginning of the transmission, and then every 10 minutes it will retransmit that code out through the transmitter. So this is the basic circuitry, the basic block diagram of how this thing works. And now I'll show and demonstrate the actual circuit, which is right now in breadboard form. So stand by. Here's the actual breadboard of the circuit that I have operating right now. I'm going to test it here before I mount it on a PC board here. Up here is the astable multivibrator here, which would be this one here that generates the tone that's fed to the transmitter. You can see a low pass filter. Here's the low pass filter here, and then I have an adjustment pot here. I can adjust the level. Right now I'm just feeding it through an RCA jack to a speaker here. Here's the Arduino Nano that I programmed with a call sign in it, and that is fed to the astable multivibrator up here, and that's fed through pin 9, and that triggers the output for the tone. And down here on this breadboard I've got this 555, which would be the monostable here, and that's where I generate the timer, which I can set for, well, up to about 10 minutes. I put in a smaller resistor here because I want to demonstrate it, and I don't want to wait 10 minutes to let it time out, so I put in a 100K resistor. This should allow a time of this of maybe a minute or so, with the capacitor and the resistor I have here. This push button switch here simulates the carry operated relay in the transmitter. So when I push this button, that's going to simulate the relay in the transmitter. This integrated circuit here is the NAND gate, which is the gate here, and then this is a hex inverter here, which is the two inverters that are used. So now I'm going to simulate when the transmitter is keyed. I'm going to push this, and it's transmitting the call sign. And now I can push it again, nothing happens. And this would be for 10 minutes, or 9 or 10 minutes. And then at the end of that time, it can be triggered again. This resistor, of course, will be replaced with a 1 meg resistor, which will increase the time. So now, after the timeout of this monostable, which probably is about now, I should be able to trigger it again. But you can see here, as I keep triggering the transmitter, nothing happens because this is inhibiting it from transmitting again. And the purpose of that is I want it to ID every approximately 10 minutes. So this will inhibit the transmit for approximately 10 minutes. I may put a pot in here so I can set the timer on it. Anyway, that's basically how the circuit works. The heart of this thing, it allows it to be done, is this Arduino Nano here, which I was able to program the call sign in it, and I will go over the program. It's not very complicated, and I will go over that next and show how to develop your call sign using this. Here's the program I wrote to generate the call sign, and initially you can see is integer LED equals 9. Pin 9 drove the astable multivibrator that generates the tone. So when pin 9 goes high, that generates the tone in an output. Now you can see dit and da. The dit would be the dot in the code, in the Morse code, and that would be 55 milliseconds. And the da, or the dash, would be 130 milliseconds. So every time the program calls for 55, that would be the length of time for the dot, and the 130 would be the length of the time for the dash. and then there's a pause of 115 milliseconds between those, and then there's a space of 85 milliseconds. So anyway, when in the void setup here, I've got pin mode LED as an input and pin mode pin 4 as an input with a pull-up resistor, internal pull-up resistor. So now to start this, in the void loop here, I've got an if statement, and it will read digital pin 4. If that pin is low, it will run the code below this point here, which generates the Morse, the signal. If that pin 4 is high, it doesn't do it. So by enabling or disabling pin 4, I control whether it's outputting the tone. So now when pin 4 is enabled, goes low, it starts out digital write high LED, which would pin 9, high, and then there's a delay or a DIT, which is 55 milliseconds, and then at digital write low, that pin goes low, and then there's a delay, and the delay would be 55 milliseconds. So that is the first letter. And now we're going to the next section here, digital write LED high, and a delay, a DA, which is 130 milliseconds. So that would be the dash, equivalent to the dash. And then it writes that pin low again, and then there's a delay. And then we go down, we digital write pin 9 high again, and that's another DA or dash, and then we write that pin low. So in other words, right now we've got DIT, DA, DA, or dot dash dash. We just generated the letter W in the call sign, so it's W, and then there's a pause. After the pause, digital write pin 9 high, a dash or DA, and that's the 130 millisecond duration, and then it writes that low, and then there's a delay, and then we write that pin 9 high again. It's a dash or a DIT, or the 55 millisecond, and then we write it low again, and then there's a delay. So we've got dash dot dot dot, or dot dit dit dit. That's the letter B. So the first one did W, and now we generated B. And of course, there's a pause. Then I'm in the 9th district here for amateur radio, so writes pin 9 high again with a DA, which is the dash. Then we write it low, and then we have a delay. And we do that again and again and again. So there's 4 dashes and a dot, and that would be the number 9. And then there's a pause again. So in other words, it goes down through this program, and by turning pin 9 on and off at different intervals or different times, it generates the Morse code numbers and letters. And at the end of that loop, it goes back to the beginning, and it'll do all of it over again. So if that pin 4 on the Arduino is low, it will continually transmit the Morse code identifier. And you get down to the bottom here, and this is the end here, and then it loops back to the top of the program. So after the first sending of the Morse code identifier, it will come back to the beginning here, and it will look at pin 4 again, and there's an if statement. If that pin is low, it will continue it over again. So in the circuit I built, when you initially key the transmitter, pin 4 is taken low initially. It'll go through a round of one identifier, one code identifier, and then it stops. And then after this pin 4 will go high again. After 10 minutes, that will be brought low again, and it will go through the code again and send the Morse identifier, and it'll just keep doing that over and over. The actual tone, like I say, is generated by the 555 timer, operating as an astable timer. And of course that had to be filtered. The output of those is a square wave, and so I filtered out all the harmonics and ended up with just a sine wave. I'm going to do a couple more refinements to this circuit. A few things I want to add, a little filtering, etc. And then all these components will be mounted on a circuit board here. I got another Arduino Nano here. They'll be mounted on this board, and then that'll be mounted in the transmitter. So all of this rat's nest here will be consolidated into a small circuit here, and I'm sure it'll work a lot better when I get rid of these flying leads. But anyway, that was the project for today. Here's another little hint before I leave. Logic probes. This is something you want to have. Very inexpensive, very handy. It'll tell you whether it's a high or a low. You can see here a low signal and a high signal. So as you're going through and testing some of these logic circuits, this comes in really handy. It's got a red LED for a high and a green for a low, and it'll also show a pulse. There's a yellow that will blink here, and this is powered from the circuit you're using here. You just connect it across the power leads, and then the probe tip here is where you actually take a measurement. Anyway, if you have a need to generate a Morse code identifier for your ham radio transmitter, this is a way to do it. Now, as I get better at programming, which I'm pretty new at it, I talked to another fella. He says that a lot of these timing functions and that can actually be done on your Arduino. I don't know how to do that yet, but by the time I learn to do that, I can put a circuit together pretty quick. So I did it this way. But anyway, that was the project for today, and I'm going to install it in that repeater and try to get it on the air here pretty soon. So hope you enjoyed that one, and thanks for watching. We'll see you in the next one. Bye for now.